Start.
Yeah. Dear students, last class we were seeing about the classifications, okay, and last class we were seeing about the need of the pump and all those things. So today we will continue what is the importance of individual pumps. We will see the picture of how this pump will look like. Okay, so first positive displacement pumps. Okay, this applies as I told. Okay, this pump applies directly pressure to the fluid and all. Okay, each types are piston pumps or reciprocating pumps. Okay, the good example, okay, for reciprocating pump is our day-to-day life. We would have seen in our home or in streets or roadsides and all. Okay, hand pumps and all. Okay, in those days and all. Okay, this is a very familiar type of pumps. Okay, where to lift the water from greater depth and all. Okay, so this type of pumps are comes under positive displacement pump. Okay, so what are the various types in that reciprocating pumps in the sense? Okay, in that thing, okay, it is being broadly classified as reciprocating pump and rotary pump. In that reciprocating pump, these are the various other subdivisions that exist: piston pumps, plunger pumps, and diaphragm pumps. Okay, so all this comes under positive displacement pumps. Okay, how this is an example. Okay, the cross section view of piston pumps. Okay, cross section view means, for example, if you take an apple or fruit, or if you cut into half, you can able to see the flesh. Like that, if a device is being to understand the better understanding of the device, okay, the device will be cut. Okay, it will be okay, like that. You just imagine, okay, how the cross section view of the pump will look like and all. Okay, so this where the rotary action. Okay, this type is double acting reciprocating pump, like a setup. Okay, where the piston, okay, there will be a cylinder and piston. This this piston will move to and fro within the cylinder. Thereby there will be a suction of liquid and there will be a discharge of liquid. Okay, this is about piston pumps. Okay, another type is like a plunger pumps. Okay, it is also okay for example similar like a piston cylinder. Okay, where this you imagine like a rotary ball like a thing. Okay, or ball like a thing. Okay, spherical ball like a thing. Whenever there is a piston moves to and fro with respect to the cylinder, okay, by means of a crankshaft. Okay, when you give some rotary motion, so that during the suction, okay, it sucks the liquids, and during the suction this valve will be open and this valve will be closed. Okay, during the discharge, when this piston moves ahead, okay, by the time the liquid gets compressed, by the time this valve will get closed, this valve makes the opening closed and this valve makes the opening open. Thereby it pressures the liquid, it gives a huge pressure to the liquid, it gives a huge energy to the liquid. Thereby it gains energy. Thereby you can able to lift the liquid. Okay, this is how the plunger pumps will look like. Similar like a thing, diaphragm pumps. Okay, this is nothing but a yellow thing which is mentioned. It is nothing but a diaphragm. Okay, this diaphragm you can able to pull or push. Okay, whenever there is a pull, okay, the liquid gets sucked inside. Whenever there is a push, okay, due to since the diaphragm is being connected to the crankshaft, okay, there may be chances of concave like a thing or convex like a thing and all. Okay, so when there is a push, okay, the diaphragm elongates like this, so thereby the liquid give a pressure so that it elevates to the higher level and all. When the diaphragm gets pulled, okay, like a concave like a thing, thereby low pressure prevails so that the water gets lifted. Okay, this is with respect to the diaphragm pumps. Okay, then coming to the rotary type. Okay, rotary pumps and all. Okay, as I told, okay, there are different type of rotary devices. Okay, single rotor, multiple rotor like a thing and all. Okay, so this comes under gear pumps under rotary devices and all. Okay, there will be some gears. Okay, moving gears and fixed gears like this. Okay, and the liquid goes inside. Okay, when this movement, okay, you just imagine like a gear like this setup. Okay, when two gears will move in and okay, one is fixed and another will be in a moving. Okay, when these gears get locked, and when it is moving with the fixed one, okay, thereby the liquid that get caught will get compressed and it gets discharged. Okay, so the liquid it is not been sucked. Okay, the liquid goes inside, gets compressed and gets discharged. Okay, this is the difference between earlier reciprocating pump and this pump and all. Okay, so another type of pump is called a screw pump. Okay, all these pumps comes in the rotary devices and all. So the liquid goes inside. Just imagine like a screw rotors. Okay, just imagine like a screw rotors. Okay, screw rotors in the sense like a, when you okay, you can able to see some threads over the pipe like that. Okay, like that. You just imagine like a thread, like a thing. Okay, so fixed one. Okay, stator part and rotor part. Okay, so such that, okay, like a gear, like a setup. Okay, here there will be a grooves. Okay, inner grooves and outer grooves. Okay, so, fixed pipe, and over that there will be some screw like setup, so that the liquid get caught, get compressed, and it is being pressured out. Okay, it is being pressured out. Okay, we need to give some rotary motion for this. Okay, that way the liquid gets sucked inside and it gets thrown out. Okay, another type of pump is called as globe pumps. Globe pumps in the sense it's almost like a modified version of gear pumps and all. Okay, for example, okay, two lobes, these are called as lobes. Okay, just a rotary devices and all. A flow goes inside. Okay, two lobe, one rotates in a clockwise, another rotates in anti-clockwise. This is a must. Okay, you can see the arrow mark and all. Okay, so one rotate in a clockwise, another rotate in a anti-clockwise. Just imagine. Okay, our clock means clockwise and all. Okay, another one rotates in a clockwise and this rotates in a anti-clockwise. So thereby the liquid get caught between these lobes and discharged with very high pressure and all. This is how the lobe pumps will work. Okay, so why? Okay, you might be asking why different type of pumps. The thing is, since we are going to handle different characters of liquid, it may be a gas or it may be a pure form of liquid, say like a water or alcohol or some thing and all. So say like water mixed with the solid, gas mixed with the solid. Okay, different characteristics. Okay, so that even a jam like a material has to be transported through the pipe. For example, if it is like sand jam, okay, it has a different characteristics. Okay, gas has a different characteristics, water has a different characteristics, alcohol has a different characteristics. You just imagine jam like a material. Okay, it has to be transported and all. Okay, thereby, okay, you can able to, if you can't able to use any reciprocating pump and all. Okay, it can be transported through this type of lobe pumps. Okay, so each pump has its own advantage and disadvantage, its own benefit. Okay, what type of okay, which pump is being used for handling solid liquid having solid particles. Okay, liquid having higher viscosity, lower viscosity, and so on. Okay, so coming to the next about the dynamic pumps. Okay, dynamic pump, there are two type of thing. Mainly centrifugal comes under dynamic pumps. Okay, so it has important. Okay, centrifugal pump looks like this. A centrifugal pump looks like this. Okay, I couldn't able to get a real actual image of this thing. So in due courses, I'll show the real type of centrifugal pumps and all. Its cross-section view will be looking like this. It has important part called impeller, casing, and that special type of casing. Okay, this type of casing. Okay, has the path for movement of the liquid. Okay, this type of casing is called volute casing. Okay, and this is where the suction. Okay, and this is where the discharge. Okay, it happened. Okay, in that impeller there will be some grooves. Okay, those are called as vanes. V-A-N-E-S. Okay, this is how the centrifugal pump look like. There are different type of casing. Okay, volute casing or diffuser casing. Okay, volute casing. Okay, that vanes arrangement, based on the vanes arrangement, okay, different type of casing and all. Okay, okay, if it is a, okay, it is an example of vanes. Okay, you can able to see that grooves, waves, veins like that. Okay, this is a setup of impeller. Okay, open impeller, semi-open impeller, and closed impeller and all. Okay, what is the difference between, for example, if it is a thin liquid, if it is a thick liquid, okay, if it is a thick liquid, if you are using a open impeller, then it can able to transport to the open impeller you need to prefer. If it is a closed, means okay, pure water, it can be closed. Okay, instead if I take a jam like a thick liquid and if I use a closed impeller, means this will block the the material goes and blocks inside the veins and all those things and all. Okay, so depending on, okay, one motor company will have, okay, different designed veins, okay, impeller designs, okay, in a different materials and so on and all. Okay, so this how a pump will be connected. Okay, it may be a reciprocating pump, or it may be a centrifugal pump, or any type of pump. Okay, it will be connected like this and delivered to the overhead tank. Whenever we need, we can able to take the delivery from the discharge head. Okay, now usually they will tell that a suction head, discharge head like this and all. Okay, so the level of the liquids, okay, till the eye of the pump, we call this a suction heads. From the eye of the pump, wherever it is being discharged to the overhead tank, okay, that is called as delivery head. Okay, with this I will stop today. Thank you.